Okay, this is Encore Lesson 101 about mean absolute deviation. So we know what the mean is. The mean is the average of a data set. We find that, because it would be mean of me to make you do it like this, by hand. We add up all of our data points, so if there's 5, we add them all up, and since there's 5, we would divide by 5 to find our mean, the average. And so the mean absolute deviation, deviate means to move away from, so we're finding out the average of how far away the other data points are from that mean, from that average. So we have an example here. We have the prices of 8 lunches are 10, 8, 3, 5, 9, 6, 7, and 8. If you add up all of those numbers and divide by, there are 1, 2, 3, 4, 5, 6, 7, 8. So if we add those all up and divide by that 8, we find that our average, or our mean, is $7. So then to find the absolute deviation, we're finding out how far away all of these other data points are from that mean of 7. So in order to do that, we can use a number line to help us visualize how far away we're moving or deviating from that mean. So we plot the other numbers in our data set on this number line, and we count how far away they are from that mean. So you can see here they use the example of the $10, and they drew little arrows to represent that it is 3 away from our mean of 7. Now you're going to do that for all of the data sets, points in the data set. And they actually make a list here of all of those data values, and they use the number line to see how far away they are, and they list that distance underneath. So you can see again, like that 10 is 3 away from our mean of 7. The 8 would only be 1 away from that mean of 7, and so on. They do that for all the other data sets, the numbers in the data set. Now down here, you can see that in order to find the average, the same way that we find the mean, we need to add up all of those distances, all of those deviations, how far away they are from that mean, and we get a total here. Here we get 14, and then we divide by the number of points in that data set, much like we do for the mean, and there are 8. Like we said on the top there are 8 data points in this data set, and we get a mean absolute deviation of 1.75, which means that on average, these numbers are about 1.75 place values away from that mean, which is a pretty small mean deviation. So we'll go down here a little further and we'll try a couple. Number 1 here has the ages of people on a team in years. You can see that we have 1, 2, 3, 4, 5 numbers in our data set. Now the mean, if you add those all together and divide by 5, we get a mean of 10. So to find the mean absolute deviation, we need to find the distance that all of these numbers in the data set are away from 10. We're then going to add them up and divide by that 5 the same way we do the mean to get our average, how far away they are from that mean. So 9 is 1 away from 10. 12 is 2 away from 10. 10 is 0 away from 10, so we'll actually write the 0 to represent that. 8 is 2 away, and 11 is 1 away. Now, much like they did up here, we're going to add up all of these deviations, how far they are from the mean. So we get, let's see, 6. Up here, like we did, we're going to divide by that number of data points like we do to find the mean in the first place, which is 5. And we're going to get a mean deviation of 1.2. So on average, all of those numbers are about 1 2/10 places away from that mean. We'll do one more. We have Sam's test scores. We have 1, 2, 3, 4, 5, 6 numbers in our data set. When we added all of these 6 together and divided by the number in the data set, we get a mean of 84. We're then going to find out how far away these numbers are. 86 is 2 away from 84. 71 is 13 away. 92 is 8 away. 84 is 0 away. Again, we'll represent that with a 0. 76 is also 8 away. And the 95 is going to be 11 away. Now we're finding that average, much like when we find that mean. So we're going to add all of these deviations, or how far away they are from that mean, together, and we get a total of 42. And to find the average deviation, we're going to divide by that number of the data set, the data points in the set, which is 6. So we're going to divide by 6, and the average deviation from that mean is going to be 7. So if we compare these two, the 1.2 and the 7, we can then start to compare the mean absolute deviation between data sets. You can see that this 1.2 is much smaller, which means that the numbers in this data set were much closer to the mean than in this other data set. You can see that these ones have an outlier, this 95 being a lot higher than some of the other numbers in the data set, and you can see that this 71 is a lot lower, which means that this mean absolute deviation is a lot higher on average because those numbers are so spread out. So these are a little tighter and closer together, and these ones are a little more spread out and a little more all over the place. And we can look at that mean absolute deviation to help us understand that.